In this example, we're given a frequency distribution. And because this example involves several parts, if you want to skip ahead to a certain part, just look in the description below to get to that timestamp. So first of all, the age of mothers in years are these classes or intervals that were given here. And their frequencies would be the births that each class has. So, or each age group has. If we want to determine a cumulative frequency, what we're really doing here is finding a running total of frequencies. So the first value is, well, just 2,500 because there's only that one value there at that point. But to get this next value of cumulative frequency for the age group 15 to 19, we're going to add together the frequencies of both 15 to 19 and anything before it. So I've got my calculator over here on the side, and that's how we get this running total of frequencies up to the point of the age group 15 to 19. And we can keep doing this. So if I want to get the next cumulative frequency, I'm going to add these three frequencies together. So to this, I will add the next frequency for the age group 20 to 24. And notice I get a cumulative frequency for age group 20 to 24 of approximately 1 million something. So I can continue doing that through my chart. By the very end, what I really should have here in this last cell is the total of all the births for all the age groups. And you can confirm that just by adding them all together. In Part B, we're asked to go a step further and construct a cumulative relative frequency distribution. Notice the additional term relative means that we're going to take this distribution, the cumulative one, and express those frequencies relative to the total, this approximately 4 million value right here. So I've started that process over here on my calculator. If you wanted to do this by hand, you would take the cumulative relative frequency of just this age group, which was 2,500, divided by the total. That is expressed in scientific notation, so I would need to move that decimal 4 places to the left, and I get 0.0006. For the next age group, ages 15 to 19, don't forget to come back here and grab this value, because this is a cumulative relative frequency distribution. So you want to make sure that you're using these cumulative frequencies. Notice I've used that here. I divide that by the total of the frequencies, and which should be the last cell here. And that's how we get 0.0584 for a cumulative relative frequency for this age group 15 to 19. And you can continue doing that in your calculator, or you may choose to go to StatCrunch at this point, because if you're thinking, wow, I'm doing a lot of calculations, what can StatCrunch do for me? So to access StatCrunch, you can click on this little icon, and you would select Open in StatCrunch. Now, one thing I do notice is the age of mothers is written in a format that StatCrunch is not going to do anything with that, with these symbols and things. I think it was trying to interpret the dash in some kind of way. But when we were doing these by hand anyway, we would find the midpoint of each interval. And to determine the midpoint, we look at consecutive minimums and we find the distance in between them, or the average, in between them. So we want to do 10 plus 15 and divide that by 2 to get this midpoint, 12.5. So that would be the midpoint that we could place here. To get the next one, we would do a midpoint, find the midpoint between 15 and 20, which should be 17.5, and so forth and so on. So I'm just going to go ahead and fill in that first column with showing the midpoint, so at least the data is in an interpreted form that I can use. Another thing about StatCrunch is it will not do or will not determine cumulative frequencies for us. So we have to type in those values here. And so if I'm going to let StatCrunch determine the cumulative relative frequency, I do need to type in what I got here in part A. So I'm going to come up here to the top and just name this CF, short for cumulative frequency. And I'm going to type in these values that I had in part A, and I'll finish doing that. And after you've typed in those cumulative frequencies, now we're going to determine the cumulative relative frequencies all at once inside StatCrunch. So I'm now in this fourth column, and I'm going to come up here to Data, Compute, and Expression. Here I'm going to build an expression where I find the cumulative frequencies. So I'm going to add that, cumulative frequencies. I just double clicked it there. And I divide by the total. Remember, the total was this last cell in part A. And I can click OK. I can give it a label. So let's label this cumulative relative frequency just so that we can keep track of what it is. And I'm abbreviating there. I'll click Compute. And it says it's added a new column. I'll just click the X to move that out of the way. And here are those cumulative relative frequencies. And this should match what we see here in part B. So just to confirm, for the third class, ages 20 to 24, I see 0.2721. And that was the same thing that we had here if we were to calculate that by hand. So it's optional, to use StatCrunch here. You could decide, was that more time saving to you than to calculate these on a calculator? That's up to you. All right, so up next, we've got some other interpretive type questions. What percent of births were to mothers less than 30 years old? So less than 30 years old, the first class less than 30 years old is right here, the age group 25 to 29. And this is that percent, written as a decimal anyway, of births to mothers less than 30 years old because it's cumulative. It's adding up all the other classes before it, and it's expressing it in terms of its total of all the births. So the only thing left for us to do is to change that to a percent form. We could do the same kind of thing here. What percent of births were to teenage mothers? That's the age group 19 years or younger. So I come back up here to my cumulative relative frequency chart, and I'm going to express 0.0584 as a percent, 5.84. In parts E, F, and G, we're asked to create some graphs. Well, technically even select the correct graph of a sample of graphs. So in this particular one, we're looking at constructing a frequency polygon. The frequency polygon needs the midpoints of each class and its frequency. One other additional thing it needs to start at 0 and end at 0. And just glancing at all these graphs, they appear to do that, start at 0, end at 0. And I'm talking about frequencies here. Frequency starts at 0, the frequency ends at 0. Well, you might think, well, how can I use StatCrunch to help me see this frequency polygon? Remember, the frequencies were what was originally given, those numbers of births. So we could create a scatter plot of these two columns and interpret that in the context of a frequency polygon. There's a couple other things you could do here, but I'm going to just start with that. Let's start with that. So we're going to go over here to Graph. We're going to select Scatter Plot. Our X value or variable is the age of mothers, which we've already calculated the midpoint. That was really important that if you hadn't already done that, you have to do that at this point. The Y variable is the frequencies, which was originally given as just the title births. Up next, let's see, we can change the display to lines. So this will connect like little line segments from point to point on our graph. And I don't believe we need to change any of the other options. Let's go ahead and click Compute. And what we see here is kind of a squeezed in version of the options that we have in parts A through D, or choices A through D. So I can extend it a little bit to see that it matches closely what I have here in choice A. And you might think, well, wait a second, I don't have that little segment. Well, that's because the difference in a frequency polygon is it has to begin with the frequency of 0 and end with a frequency of 0. So other than that, the first and last point in the choices, what you see here in StatCrunch should match the rest of the graph. If you really wanted to see the zeros, you would have to come in and add a row before, and that row would be one midpoint before 12.5, so that would be, what's that, 7.5, and you would have to put births at 0, and the same thing down here at the bottom. We would have to go one midpoint after, so that would be 57.5, and we want births at 0. I don't know that that's necessary to make the match, but that is the difference between just a scatter plot and the frequency polygon. Then, out of nowhere, in part F, we're asked to construct a relative frequency polygon. And the reason I'm saying out of nowhere is because we have not calculated the relative frequencies. If you recall, what we calculated was a cumulative frequency and a cumulative relative frequency. So we would need to add an additional column if we're going to do this using StatCrunch. Even if we were doing this by hand, we would want to calculate those relative frequencies, and relative frequencies are defined as the frequencies divided by the total of all the frequencies. So I can quickly make an expression here as such in column 5. So let's go to compute. This is underneath the data. I'm sorry. We went to data, compute, expression. We are going to build an expression, and this is going to be the frequencies, births, so I just double-clicked that, divided by the total. And I've lost my total, so I'm going to have to scroll back up here to get that total. It was this last cell in the cumulative frequency chart. And we'll click OK. We can label that RF for relative frequency, just for short. That way we don't forget what each thing is. And now we have relative frequencies in our last column. Coming on back down to part F, we want to construct a relative frequency polygon. So kind of a shortcut, I guess, for this is to create a graph that is a scatter plot. We'll select the X variable as the midpoints, age of mothers. The Y variable is going to be RF, short for relative frequency. So that it matches a little bit better to what we're looking at in our choices, let's select lines for the display, and then we'll compute. Our graph is kind of scrunched up here, so I'm going to expand it a little bit. So maybe it will match a little bit better to what we see, it says in part D. So I can't show both of these at the same time, it looks like on my screen, because it's kind of small here. Let's see if I can move that over just a little bit more. Here we go. So comparing those two, you can see the similarities. Again, the only additional thing that a frequency polygon or relative frequency polygon will have is it begins at 0 for relative frequencies and ends at 0 as well. And that happens over here. In the last part of this problem, we're asked to construct a relative frequency ogive. And really all this is a graph of the cumulative relative frequencies, which we did calculate earlier in StatCrunch. We have those values over here on the side. So as you can see, it might be, by this point anyway, you might think, oh, I didn't really need StatCrunch. But the benefit to having done all these calculations within StatCrunch is I can quickly go to graph, I can look at a scatter plot, and I could say, you know, let's do X values are age of mothers, the Y values are going to be cumulative relative frequencies, and I connect these with the lines, compute, and here I have really close to what would be a relative frequency ogive, which is the same as a cumulative relative frequency graph. The only difference is technically these relative frequency ogives do start at 0. Notice that this one does not. So if I look at my choices, this one seems to be a better match if I'm looking at the curve and how it curves up compared to my other choices.